Hello, this video is a Reteach video on the area of composite shapes. To find the area of a composite shape, we must first break the original shape into smaller shapes. For this shape we can draw an auxiliary line to create a rectangle and a trapezoid. Alternatively, we can add another auxiliary line to split the trapezoid into a rectangle and a triangle. This will show that the composite shape is a large rectangle, a small rectangle, and a small triangle. Next we must find the area of each shape. Something to consider is the scale of the coordinate plane itself. In this case, the scale is going by tens. When finding the area we must know the dimensions of the base and heights of each shape. To find the height of each shape we must modify the distance formula by subtracting the highest point of each shape to the lowest point, so for the big rectangle we will subtract 70 and -30 and get a distance of 100. To find the base we will subtract the right point to the left point, so for the big rectangle this will be 20 minus -20 which is 40. Now that we know the base and height of the big rectangle we can find the area of the big rectangle. By using the formula, the area of a rectangle is equal to the product of its base times its height. So, 100 times 40 is 4000. Now we will do the same thing for the small rectangle and the triangle. First, we will find the base and height of each shape, and then apply their area formulas. Once again, the area of a rectangle is base times height, so 50 times 20, so that means that the area of the rectangle is 1000, and the area of a triangle is 1/2 of base times height, so 1/2 of 50 times 20 which is 500. Once we know the area of each shape, the last thing to do is to add the area of the shapes. Once we add the area of each shape, we get that the area of this shape is 5500. All of the practice problems have similar looking shapes. In our first problem, we will once again break the composite shape into smaller shapes. If we draw one auxiliary line we will get a rectangle and trapezoid. If we use two auxiliary lines we get two rectangles and a triangle. Something to consider is that the scale of this coordinate plane is going by twos. Next we will find the height of the big rectangle by subtracting the highest point of the rectangle to the lowest point, so this will be 14 minus -6, which is 20. Next, we will find the length of the base by subtracting the right point with the left point. This will be 6 minus -2, which is 8. Now that we know the base and the height of the rectangle we can find the area of the rectangle by multiplying the length of the base and the height. So this will be 8 times 20, which is 160. Next we will find the length of the base and the height of the rectangle. Both have a base of 4 and a height of 6. Once we plug in the numbers into the area formulas we get that the area of the small rectangle is 24 and the area of the triangle is 12. The last thing to do is add the area of each shape, which will give us that the area of the composite shape is 196. The next shape once again is similar, the scale however is going by 3. Once again we will start by breaking the figure into smaller shapes. Once again we can either have a rectangle and trapezoid or two rectangles and a triangle. Next we will find the base and the height of the big rectangle. To find the height we will subtract the highest point from the lowest point, so 15 minus -9 is 24, for the base we will subtract the right point from the left point, so 6 minus -12 which is 18. Now that we know the base and the height of the big rectangle we can multiply them to get that the area of the big rectangle is 432. We will do the same to find the area of the smaller rectangle and triangle. After applying the dimensions we get that the area of the smaller rectangle is 108 and the area of the triangle is 54. Once we know the areas of each shape, we will add the areas to get the total area, which is 594. For our next problem, the scale is 4, we will start by breaking the composite shape into 2 rectangles and a triangle. After breaking down the composite shape, we will find the height by subtracting the high point from the low point of the big rectangle. This will be 28 and 4, which means that the height of the rectangle is 24. We will then subtract the right point from the left point to find that the length of the base is 8. Now we will multiply the base and height to determine that area of the big rectangle is 192. Next we will find the heights and bases of the small rectangle and triangle. After finding the values of the base and heights, we will apply the area formulas and determine that the area of the small rectangle is 96, and the area of the triangle is 48. Now that we found the area of each shape, the last thing to do is add the areas up, and get that the total area of the composite shape is 336. For problem 4, the scale is going by 5. Once again we will begin by splitting the composite figure into 2 rectangles and a triangle. We will begin by finding the area of the long rectangle, by finding the height. To find the height, we will subtract the highest number 40 from the lowest number 5, which is 35. Next we will find the base by subtracting the right number 20 by the left number, which is 15, so the base is 5. After finding the base and the height, we will multiply them to find the area, which will be 175. Next we need to determine the base and the height of the shorter rectangle and the triangle. Once the base and the height have been determined, the next step would be to apply the area formulas. The area of the shorter rectangle will be 300 and the area of the triangle will be 100. Now that the area of each shape have been determined, we can add the areas to find the total area of the composite shape. After adding the area of each shape, we get that the area of the composite figure is 575. The scale for our last problem is 10. Once again we will break the figure into a big rectangle, a small rectangle, and a small triangle. The next step will be to determine the dimensions of each shape, then use the dimensions to find the area of each shape, and finally add up the areas to find the total area of the composite figure. After adding the areas of each shape, we have determined that the total area of the composite shape is 6,150.